Welcome back again, guys. This is part 3, I suppose. Let's finish up this test. This might be the second to last. I think there's going to be one more part after this. But let's get started. Suppose c of x equals x cubed minus 22x squared plus 30,000x is the cost of manufacturing x items. Find a production level that will minimize the average cost of making X items. Okay, keyword average cost. So to find the average, as you know, if you had a list of numbers, you would add them all up and then divide by the number of items you added. Same for this. For our cost, to find average cost, we need to divide by the number of items we had. Well, we have x items, so we need to divide by x. Okay, whenever we divide by x, we'll get x squared minus 22x plus 30,000. And then now we can take the derivative of this. Let's say this is our g of x. So the derivative of this is just going to be 2x minus 22. And now to find the production level that will minimize the average cost, we'll just set this equal to 0. And so if we have 0 equals 22, or 2x minus 22, add 22 to both sides and divide by 2 to get x equals 11. So 11 items will be a production level that will minimize the average cost. Excellent. Evaluate the integral t plus 1 over t squared. Alright, well first let's expand this out. We have t plus 1 over t squared. So t plus 1 over t. And let's FOIL this. We have t times t is t squared. 1 over t times t is 1. We have 2 of those, so plus 2. And then 1 over t times 1 over t is 1 over t squared. Alright, so we need to find the integral from 1 to 2 of t squared plus 2 plus 1 over t squared. So let's get started on this. Well, let's separate this single integral into 3 separate ones. So if we do that, we'll have the integral from 1 to 2 of t squared plus the integral from 1 to 2 of 2 plus the integral from 1 to 2 of 1 over t squared. Alright, so let's solve each of these one by one. So these are pretty basic integrals. You kind of solve integral to a power the opposite of the derivative. A derivative is you take down the power and then subtract 1, i.e. the derivative of t squared would be 2t. So to find an integral, you kind of need to think about you could think about it as t squared is the derivative to what function, and that's kind of how I think about it. So the integral of t squared, well, this is going to be, well, one more power up is t cubed, but then if we were to take the derivative of this, we would have 3t squared, and so we needed to be divided by a 3. So the 3 will cancel. Alright, so for the next part, we have 2. This one is very simple. The integral of 2 is just going to be 2t. And then the last one is definitely the most complicated out of these three. I would first rewrite 1 over t squared as t to the negative 2, and then I can solve this one just like I solved this first one, and we'll get 1 over, or negative 1 over t. And that looks great. These are all, again, bound from 1 to 2. So let's plug in 2, and then plug in 1, and subtract the two values from one another. So if we plug in 2 to this function, we'll get 2 cubed, which is 8 over 3. So 8 over 3 plus 2 times 2 is 4, minus 1 over 2, so minus 1/2. Let's now change these two fractions to have the same denominator. So let's change everything to have a denominator of 6. So we'll have 16 over 6 plus, well, 4 over 1, so 4 times 6 is 24. So plus 24 over 6 minus 3 over 6. And this all simplifies down to what? Well, 16 plus 24 is 40, minus 3 is 37. So this is 37/6. And now let's plug in 1. So if we plug in 1 to this function, we have 1 cubed over 3 is 1 over 3, plus 2 times 1. 2 times 1 is 2. And then minus 1 over 1, so minus 1. So this leaves us with 2 minus 1 is 1, plus a third. This is 1 1/3. This, as an improper fraction, is 4/3. 4/3 with a denominator of 6 is 8/6. And so now, lastly, we have 37 over 6 minus 8/6. So let's write that out. So lastly, we need to subtract these two. So we subtract those two, and what do we get? We have 37 over 6 minus 8/6, and this gives us 29/6. And this is our answer. Excellent. Find the intervals on which this function is continuous. Okay, so when would this function not be continuous? This would not be continuous whenever this is undefined. So when would you have a square root that is not defined? Well, you can't have a negative within the square root. Now, if you're in calculus, you're obviously probably thinking, well, what about imaginary numbers? Imaginary numbers, yes, that is how you get negative square roots, but that would not be continuous. This is in the realm of real numbers, not imaginary. So with that being said, the way for this to be continuous is x squared minus 2 must be greater than or equal to 0. It has to be positive. So if we solve this inequality, we'll have x squared must be greater than or equal to 2. And if we take the square root of both sides, we will have, it will be plus and minus. And so we'll have x needs to be greater than or equal to square root of 2. And x needs to be less than or equal to negative square root of 2. Here, it's important to note that the sign flipped. That's because whenever you multiply by a negative, the sign flips. So that's why. So what is the interval? Well, our interval will then be negative infinity to negative square root of 2 union positive square root of 2 to positive infinity. So this is our answer. Excellent work. Let's go to one more problem for this video. At the given point, find the slope of the curve or the line that is tangent to the curve as requested. Okay, so the function is x to the fourth times y to the fourth equals 16. And we want to find the equation for the line that is tangent at this point 2, 1. So what can we do? Well, if we find the derivative of this function, we will know the slope, the equation for the slope, and then after that we can plug in this value to find out what the remainder of our equation can be. All right, so let's solve this. So we have our equation x to the fourth times y to the fourth equals 16. So let's isolate y. We have y to the fourth equals 16 over x to the fourth. Now we can take the fourth root. We take the fourth root. We have y equals 2 over x. And this is good. So this is just our original equation simplified. We have not found the derivative. So let's find the derivative of our function now. So we have our function y equals 2 over x. So let's find the derivative of y equals what? Well, 2 over x, this is the same thing as 2 times x to the minus 1. So our derivative, we can use our power rule, multiply our 1, or our negative 1 to have a negative 2x to the minus 2. And if we can rewrite this, of course, as negative 2 over x squared. It's our derivative of our y. So what is the slope at this point? 2, 1. Well, the derivative gives us a function for the values of slope. So if we plug in 2, because 2, 1, this is our x value, our y value. So let's plug in 2 to our equation, and we will get negative 2 over 2 squared, which equals negative 2 over 4, which equals negative 1/2. Therefore, our slope is negative 1/2. Okay, so we know our slope is negative 1/2. What else? So how can we figure out the equation for the line? So let me illustrate this a little bit. So we have some function, and it probably curves somehow. And then at 2, 1, so we go over 2 up 1, let's just say it's here. So we need to find our tangent. Now we just figured out that the slope of this tangent is negative 1/2, but now we need to find the equation for this tangent line. So this is just a line, and so we know that we can use y equals mx plus b. We found our slope. Our slope is negative 1/2. So we have negative 1/2 x plus b equals our y. And what else can we do? Well, or what else do we know? Well, we know this point. We know that whenever x is 2, y is 1. So let's plug in those numbers. So we have 1 equals negative 1/2 times 2 plus b. So negative 1/2 times 2, that's going to be negative 2 over 2, which is just negative 1. So we have negative 1, or 1 equals negative 1 plus b. So we can move our negative 1 over to have 2 equals b. Therefore, we know our b. So our equation for our tangent is y equals our slope, which is negative 1/2 x, plus b, so plus 2. So y equals 1/2 x plus 2 is the equation for our tangent line at the point 2, 1. Excellent work, guys. All right, in our next video, we're going to finish up this calculus test. I hope you have learned a lot, and if you have any questions or comments for me, please leave them in the description below. See you next video.